You know, the way the climate change impacts are diagnosed now, there is always some expert or group of experts who are saying, yes, this is climate change impact and this is natural variability, or this would have happened without climate change. So there are many details. There is, of course, the detection and attribution business where you say you detected some change or some event like a heat wave on in a particular state in India, and then few days later, literally, you can have weather, extreme weather attribution, weather event attribution, or some such group can tell you this event was made X% more probable by climate change. And there are details on how they do it, because you have to use a model to say what would have happened without climate change and what happened because of climate change, and then say climate change made it worse. Or you can say this is an event that would have happened anyway, but climate change made it much stronger, more intense. Or you can say this would not have happened without climate change. So this is a bit of a tough business, because this idea is to use such attribution exercises for legal liability issues. If I was a lawyer, I would easily argue away that this model's such attribution is not reliable. And I have podcasts on how heat wave attributions may not be as reliable as we think. So the idea is not to dismiss attribution, but to say in a cost-benefit analysis and in limited resource world, how do you want to manage resources for attributing legal liabilities versus taking actions to reduce the impacts a priori, resilience, adaptation, and so on. Nothing is dispensable or indispensable, but legal liability ideas will play out as we go forward, because already there have been cases where kids put a case on the government and the court ruled with the kids saying yes, government should do something, and so on and so forth. So we'll see many more examples of such things. So coming back to AI, what can AI do? So this is work by NASA that says an opportunity for large language models in the co-production of climate impacts. Well, I wouldn't say co-production of climate impacts, co-production of diagnosis of climate impacts, as one would say correctly. So researchers at the NASA Goddard Institute for Space Studies in New York have asked, can the skill of LLM at interpreting natural language and building code enable users to generate individually tailored climate impact diagnosis based on simple queries? So this is a project led by Michael Hendrickson. You can look up more. Here is a schematic of how that works. So the climate Seymour tables, so they are basically, you make many simulations and you store them away, and then you have large language model like GPT-4 base model. You do some calibration, fine-tuning, and use the fine-tuned model to start taking user queries. You know, LLM models are basically good at learning things and then being able to answer questions based on what they learned. So GIS input bounds on customization and interpretation of results. So there is a model database that the LLM model can ping and look for answers on climate impacts based on user queries. So there are user queries coming in again and feeding into the fine-tuned model, which is getting input from the GIS model on this side. So then you get to the point where the user query takes us to the GPT-4 model returning correct climate diagnostic data set. Then it goes to GPT-4 advanced data analysis, and you have additional chat querying. So you have, let's say you get one answer, you say, no, that doesn't make sense, and then it says, what additional data can you provide me to make a better judgment, and so on. So I'm just kind of paraphrasing here. So then you produce relevant graphic or statistics. Relevant graphic or statistic is produced by GPT-4. So here, show me the monthly mean temperature for December 2200 under a highly increased emissions scenario. wow, this is talking about projections, and then models have done projections just like CMIP 6, and you are going to store them and use that as a database to train the model, and then you're going to give GIS as one model to answer some questions, let's say like this one. Hopefully there is also ideas on how this can come with uncertainty as well. So use RYB coloring scheme, so red, yellow, blue, I guess, RGB, RYB, center the map on 180-degree latitude. So voila, you get your map here of 2200 December 2200 temperatures. High latitudes still look cold and tropics still look warm, but there are some hot spots. 2200, not even 2100. What do you want to do with it? Well, this is just an example, but you get the idea that now LLMs can go pretty far in helping individuals do their own diagnostic, because the ChatGPT or whatever GPT model, LLM model, is ready to deal with your queries. There are already predictions going on. As I said, I want to read this a bit because this is where the biggest payoff is already happening, or at least they are beginning to give a run for the money to the dynamic models and forecast centers, and centers like ECMWF, European Center for Medium Range Weather Forecasting, is already got a AI-based prediction effort, and other centers are doing the same as well. Google DeepMind, which we already mentioned, has a approach called GraphCast, which I already mentioned before in the basic AI, key AI concepts. DeepMind's GraphCast is a machine learning based weather forecasting method that seeks to improve weather forecasting and reduce their computational cost. The latest version can be run at a fraction of a standard weather forecasting model and on a personal computer as opposed to very expensive supercomputers. The GraphCast approach enables 10-day weather predictions at unprecedented accuracy in less than a minute and opens up new possibilities that have historically been computationally too expensive to be mainstream. 10-day forecast, first of all, there has to be predictability for 10 days, and at mid-latitudes we know that there is predictability at 10 days based on our models, because predictability is again a model derived metric that if you don't understand, don't worry about it. But what if AI says even in the tropics predictions can be done for 5 days to 10 days? That will be amazing. And then GraphCast can do it in less than a minute. That will be stunning, right? So its predictive ability and forecasts are more supportive of severe weather events and natural disasters, including tropical storms and extreme heat. There you go. So they are already in the tropics. Climax is a UCLA and Microsoft effort. Read one more. Recent advancements in climate modeling primarily rely on physics-informed numerical atmospheric models, while this translates to an increased ability to model more complex nonlinear interactions among multiple variables. They demand significant computational resources. Machine learning is an essential step in solving forecasting problems. Climax attempts to fill the gap through a flexible deep learning model that can be used on a wide variety of heterogeneous datasets while streamlining computing costs and maintaining generalizable usage. So when so many minds are at it, you know that it's important, as well as that we will have success and we'll have multiple models, and then they'll be competing with each other to say who is doing better, and they will keep making each other better as well, and they will tell you what are the data needs to do them better as well. So we need to collect more data to keep on doing this better. But because remember, AI needs a lot of data, and model output can also be used as data, as we saw here, right? NASA Earth System Digital Twin. We already talked about what digital twins are. This is XView2, collaborative effort backed by the Defense Innovation Unit of the Pentagon and Carnegie Mellon University Software Engineering Institute, which brought together various research partners, including Microsoft and University of California, Berkeley, to rapidly identify and categorize the severity of damage to buildings and infrastructure in disaster-affected areas. So here is Islahiye, Turkey, which got hammered by earthquake recently. So this is satellite imagery from Maxar Technologies and output from XView 2. You can see how much clearer this is with the help of AI. So here attributed to UC Berkeley Defense Innovation Unit, Microsoft, and so on and so forth. So already applications are being made, and you can see how disaster management can benefit from these efforts. Let's push forward a little bit to talk about barriers to progress. Obviously, data, and sharing, not just collecting, but sharing, making it freely available in near real time, quality controlled, etc. Equity, again, trust. People have to be trusted. If you are crowdsourcing data, there is a quality control issue, but people have to trust the people who are gathering your data that it will be used properly and that the benefits will be returned to you as well in one situation. The other is whether the AI models are being equitable and are trustworthy for all, right? Workforce training is of course needed. Policy plus governance issues are already being discussed in various contexts for AI, whether AI regulations are in place, what they should look like, and so on, and the deployment of these tools, of course. Strategies to address data scarcity, I won't go into the detail, but here is Climate Change's AI data wish list. In 2020, Climate Change AI created a data set wish list for enabling identification of which data sets needed to become available to enable AI technologies to address climate change. They are given various classifications based on perceived problems or needs within each specific field of data. So public needs public and needs structure, private needs to be released, scattered needs collation, proxies needs to be inferred, and scarce so needs more collection. So here are the data categories. Overarching data sets such as satellite, LiDAR, and materials design, etc., with various data types fitting into these categories. Electricity systems, power grid systems, solar power, wind power, aggregated electricity, power grid data for predictive maintenance. I have sinus problems. Disruptive future technologies like nuclear fusion data for disruption detection, battery operation and optimization, transportation. Of course, you have freight activity for optimization, traffic counts for infrastructure design, EVs for charging the infrastructure, urban mobility for infrastructure design, and so on. You have buildings and cities, industry, climate mitigation, climate prediction, social impacts, individual actions and collective decisions such as consumer climate preferences for facilitating behavior change towards reducing carbon footprints, consumption overall, and global policy data set as well. Okay, what is under workforce development then? Investing in next generation of AI for climate and nature workforce. So you can call it AI for climate and nature workforce. There you go. Several initiatives are already underway to develop interdisciplinary curricula to facilitate the convergence of AI and domain-specific science. So Oxford Intelligent Earth AI Center for Doctoral Training in AI for the Environment, National Science Foundation's Learning Earth with Artificial Intelligence and Physics, LEAP. National Science Foundation has another initiative, AI Institute for Research on Trustworthy AI in Weather, Climate, and Coastal Oceanography, the convergence center that will create trustworthy AI for environmental science, revolutionizing the prediction and understanding of extreme weather and ocean hazards. University of Southampton, University of Albany, so everybody is trying to get into it. At IIT Bombay, we are moving in this direction with a new program in climate and sustainability, the first one in India along these lines. And there is, of course, AI for climate that I'm trying to do. You know, I'm not an expert, but we need to learn how to use the AI tools for climate science, detection, impacts, water, sustainability, energy, buildings, infrastructure, transportation, and so on. Workforce strengthening, recognizing workforce gaps, Block Power, an AI-powered building retrofitting company, runs programs to upskill candidates from vulnerable communities with AI and ML-based construction training that incorporates both AI theory and applied learning through augmented reality technology. Workforce participants have also driven data collection for air quality that feeds back into targeting models. So as we keep saying, AI will take away jobs, it becomes very important to upskill people or retrain people, not just retrofit building, but retrofit people with skill to survive in an AI world so that they don't get unemployed and then make crazy choices in elections and so on and so forth. Okay, so I have a bit more to read. Let me stop this here and we'll come back and look at some examples. Okay, so this is already 16 minutes, so let's leave it at this for now.